Everyone, I need you to understand though, I really do appreciate the amount of murmur that I hear regarding math. Like as a math teacher, that like makes me the happiest. Because think about it. This is not the most popular subject in the world, but you guys are actually taking the opportunity to butt heads with other people to see if you're walking the same path. So don't lose that. Okay. I hope that that spirit in itself will actually help you make lots of friends, hopefully not too many enemies, and ultimately help you succeed in your future. Okay. Let's do this. That was working. Okay, so in the spirit of not only doing this as a warm-up, but also to help people who might be joining us who didn't get a chance to practice as much yesterday, I'm going to go through every single step one by one, try to do a quick explanation of what it is that we are supposed to do, and then do it. Just to remind you, instead of doing a whole bunch of steps that we've learned when we first started chapter 3, we've sort of grouped a lot of that together. I separated it earlier just so it's more sort of manageable in my opinion, but I think like Yusuf, I confused him. So I'm glad that we're here because it's more compact, more concise, and it explains everything. Domain, I think you understand. The next thing we're going to do is talk about intercepts. What does that mean? If x equals 0, what is y? Or in other words, what is f of x, right? And if the y value is 0, in other words, if f of x is equal to 0, what is x, right? That's what we're going to figure out. Then we will look at asymptotes, right? Asym. And what is that? For vertical asymptote, you're essentially checking when is denominator going to equal a 0, right? When is it going to approach 0? Because the smaller and smaller the denominator is, the entire fraction will get bigger and bigger and bigger. And then horizontal asymptote, as opposed to just saying, oh, the numerator is a 1, and you just assume the fraction can't be a 0, like all that hocus pocus thing that you didn't like, Yusuf, right? Instead, you're going to check end behavior. So what you're doing is, as x approaches positive or negative infinity, what does the function, what does a y value approach? Tell me what the end behavior is. And the end behavior, if it's approaching a 0, then you know that that's an asymptote. If it's approaching a 1, that's an asymptote. If it's approaching a -5, that's an asymptote. That's how you know. And lastly, we do the chart method. We figure out what the intervals are. Intervals. You put all your vertical asymptotes and your x-intercepts here to check for signs. And then you put all the potential binomials or whatnot that could change the sign of the entire function. We multiply everything to give me what the actual sign of the function is at the very end. Okay, I'm going to do all that here. I'm going to erase this. I'm going to draw the chart here. Here we go. Domain. X is always going to belong, as far as I care, really, going to belong to real numbers. However, x squared minus 9 cannot equal a 0. Well, you can do it in your head, but let's be real here. It's in your best interest. If you see that something can be factored, do it before you do anything else so that you have both of these forms of the function available to you. It means that x cannot equal a +3 or a -3. Why? Because +3 and -3 will make the denominator a 0, and that automatically links to the vertical asymptote. Okay. Intercepts. If x equals 0, that means f of 0 is what we're looking for. That is 0 over 0 minus 9. That's essentially 0 over -9. That's a 0. In other words, my x-intercept is 0, 0, which means vice versa. The y-intercept is also 0, 0. just in case, let me test it. If f of x equals 0, in other words, if my y value equals a 0, then my numerator equals a 0, which means x equals a 0. Therefore, my y-intercept is 0, 0. If you're not following my colors, I'm going to use blue and red. If x is a 0, that means if my x is a 0, then I plug in 0, 0. My y value is a 0. Okay? In the same way, if my y value is a 0, that means my numerator equals a 0, which means my x value has to be a 0, right? Because remember, right? This part. Okay, my asymptotes. I don't know why I wrote that. Okay. Vertical asymptote, again, I already told you, it directly connects to our restrictions in the denominator. None of these are wholes. So there's going to be a vertical asymptote at 3 and -3. Horizontal asymptote is where we need to do a little bit of math. Your skills from yesterday will come in handy. If you plug in infinity, let's say as x approaches infinity, right? Don't write this just yet. That's going to be infinity over infinity squared minus a 9. And what's a minus a 9 compared to infinity? Nothing. So it's basically infinity over infinity squared. Anything, because infinity is a number, you essentially get this, and this is not a quantity. Right? You can't actually graph that. It's undefined. And so before you even plug in your infinity, you need to simplify it. When in doubt, when it's like this, I would like to recommend you factor out an x, just like we did yesterday. So f of x is actually equal to x multiplied by 1. And then x squared minus 9 is divided, or it factors out an x, giving me x minus 9 over x. Look at it, and if you don't believe me, use distributive property to multiply this out. You should get x squared minus 9. And again, we haven't made the x value equal to infinity. It's just some number. So some number divided by some number is going to be 1. So simplified, this is equal to 1 over x minus 9 over x. Now we can plug in infinity if we want to. As x approaches positive infinity, you know what? I'm going to do the positive infinity on the right side because my eyes naturally go to the right because the infinity is on the right side, right? As x approaches infinity, f of x is going to be 1 over infinity minus a 0. Because 9 over infinity is essentially a 0. So this approaches 0. From the positive side or negative side? Yeah, positive. It's a positive fraction. Think about it. This is a positive 1 over a million. Well, it's going to be 1 over 1,000, 1 over 10,000, 1 over 100,000, 1 over a million, 1 over a billion, 1 over quintillion, whatever, right? So it's still above a 0. It's larger than a 0. Yes. Pardon me? Well, in this case, right, it's 1 over x minus a fraction. So yes, so 9 over x, as x gets larger and larger and larger, this fraction right here becomes more and more irrelevant. So we don't need it. Like it becomes closer and closer to zero. So we essentially call it a zero at that point. So there's that assumption that we make, right? As x approaches negative infinity, f of x is going to be 1 over a negative large number minus 9 over a negative infinity. It's sort of like saying a plus 9 over infinity, that's plus a 0. Which doesn't really matter. It's still going to be a very small negative number. It approaches 0 from the negative side. And everyone, I'd like you to know, while some people are copying this down, the more types of questions you do, the less you will be surprised on a test. Let's say I give you a fancy number or fancy equation and you're working through and you get all these different, just like, and you might be thinking, whoa, my chart doesn't seem to quite agree with my horizontal asymptote. But in your practice at home, you might have thought, oh, I've seen something like this before. That will build confidence. Okay? You have to give yourself the opportunity to do this every day, please. No matter what other people say, okay? You need most practice in 2 subjects. One will be language, and the other is math. It's the only courses that there's no question. You just keep on doing it. Here we go. So let's plug it all in. Oh shoot, I need to chart. I need space for chart. Oh man, okay. See? So my simplified equation is, well, there is no simplified. X could change the sign. X plus 3 could change the sign. X minus 3 could change the sign. If you don't like this, you can always just write x squared minus 9 if you want to. I think it's better to do it this way because we have a negative 3 that's a vertical asymptote. We have a positive 3 that's a vertical asymptote. And I have a x-intercept. Plugging in. Let's try negative 4. Negative, negative, negative. That means f of x will be a negative. Negative 3 is a vertical asymptote. Let's try negative 1. Negative, positive, negative. This is going to be positive. Then I have a 0. It's the x-axis. Let's plug in a 1. Positive, positive, negative. It's going to be negative here. That is a vertical asymptote. And then let's plug in a 4. Positive, positive, positive. That's going to be a positive. Okay, all that's left is to draw. So I'm going to use my chart. Negative 3 is a vertical, positive 3 is a vertical. I will have something like this and something like this. I will have a horizontal asymptote. It approaches 0. So I'm going to have, maybe I should use some colored dots instead. Okay, so y is equal to 0, x is a 3, x is a negative 3. What else is there? Y-intercept and x-intercept, they're both right here. If I approach negative infinity, I'm beneath 0. Zach, you like that arrow? Okay, coming from the left. Appreciate it. Okay. And then as we go positive infinity, it's above the 0. If I am to the left of the vertical asymptote, I'm down here. If I'm on the right of the vertical asymptote, I teleport up here. If I'm on the left of 3, I am down here. And if I am to the right of my 3, I am up here. Connect the lines. You see it. One, 2, 3. Yes. Good question. So the question was, you just told me that there was a horizontal asymptote. Why are we touching it? Why are we crossing it? There's 2 reasons that I can use to explain. The first one, it's a very quick and dirty explanation. Locally, anything can happen. So locally, like where all the action is, the horizontal asymptote sort of doesn't really play a role. The better explanation is horizontal asymptote, the definition of it is actually, it's just the end behavior. So we don't actually care what happens here. The horizontal asymptote only talks about how we end, how we finish. Okay? Yes. So basically, the horizontal asymptote applies to the end of the asymptote. Yes, the horizontal asymptote specifically refers to the end behavior. Just about anything can happen locally. No, vertical, it will always, as the denominator approaches 0, it will always. Yes. Yes, absolutely. Any questions? Okay. For the sake of time, everyone, I don't think I'll be able to do example 7. However, the answers and all the details of it is basically, I've done it by hand, I scanned it by PDF, and I put it on our Brightspace. You will see that all the steps that we follow are exactly the same for example 7, but you will find that it actually doesn't help you. And let me show you that answer key right now. Here. Oh shoot, I have to download this if I want to rotate, don't I? Okay. Open. Then rotate clockwise. For example 7, so this is what we did, example 5. Good job here. Beauty and symmetry, right? Yeah. For example 7, if you work through all the different aspects, B, I, A, and C, this is the graph that you get. You get a dot right in the middle. You know it's going to be above the horizontal asymptote and it's going to be below the asymptote. There's no vertical asymptote. There's nothing to help you. So you don't know what the action is in between. And in times like those, which I'm probably not ever going to give you this on the test. In times like those, you only have one choice, and that is use some more action sequence. This is example 7. So I'm showing you right now the answers up there. And I don't have time to do it because I do want to spend the rest of today's class trying to get you to wrap your head around oblique asymptote. Okay. Any last questions before we begin? No? You know, I know it's tough, so I gave you a little artwork to make you feel better as you move along. Okay, do your best. We are going to move into which example is oblique asymptote? Example 3 and 4. So let me quickly explain what oblique is by definition, and then we'll do some examples where you see it in action. Share, here we go. Oblique asymptote, up until now, we had a vertical asymptote and horizontal. Yes? Actually, let me stop the video here and then